In this analysis, we are going to describe the linear model for a case study. This case study is related to the faculty members data. That faculty member data relates from the PalmBeach University, right? So we have to implement a model. We have three variables here because students are complaining that the teachers are giving the more time to the publications rather than they are focusing on the teaching. So three variables we have in this analysis. One variable is called salary, and second variable is called publications, and third variable is called evaluation by students. Evaluation by students in a scale of 1 to some number like 10. Number of publications, the article published in journals like 5 articles in a year or a 4 article in a year, and salary is a scale. So all of the three variables are scaled variable, and we have to focus on salary because this is our dependent variable and these two are our independent variable. Independent variable are called predictors, and dependent variable is called class variable. So this is my class variable and these two are my predictors. So what is the objective of the model? The objective of the model is to predict the salary with the help of these two predictors. Suppose I am naming this variable as y, and this is my x1. This is my second predictor x2. So model will be what? Model will be y is equal beta naught plus beta 1 x1 plus beta 2 x2 plus error. This model is called linear model, LM. LM stands for the linear model for two predictors, right? So we have to build this model by a data set, and the data set comprised on 50 observations, means data of 50 faculty members there in the CS3 file. We have to, which contains these three variables, y, x1, x2, and we have to build the model by using this. So this is called linear model, and all of you are familiar with the linear model. Simple regression, multiple regression. Multiple regression has more than two predictors. If we have more than two predictors, the model is called multiple regression. If we have one predictor, the model is called simple. That model may be linear or non-linear. If we have to plot a linear model like the given in this slide, this is a linear model. If you are going to fit a non-linear model, you can do either a quadratic model or an exponential model or logarithmic model or a cubic model or a polynomial model. So you can put any of the non-linear model depending on the what is the first step. The first step is to plot a scatter graph, because a scatter graph will give you an idea whether the linear or non-linear. Suppose your scatter plot is like this. So instead of a linear model, you should have to plot a quadratic model because this is a parabola. So scatter plot initially given a sign as an idea about whether the linear or non-linear which is to be placed. Now this is the generalized linear model. How many predictors there are with the k predictors. This model is called linear model with k predictors, LM with the k predictors. What is model fitting? Steps in model are what I told you the steps earlier. The first step is problem specification. Second step is data and data cleaning. Next step is model proposal. Model propose or the proposal, which model is suitable. Fifth step is model fitting or model learning. In machine learning, it is called model learning. And after the model learning, we have model testing. If testing is successful and we have a high degree of accuracy, then deploying the model. Deploy the model. If it is unsuccessful, then you can propose another model, learn another model, again test the model. So this is a repetitive step, and you have to. So this step is which I am showing here, model learning. What we have to do in model learning? In model learning, we have to estimate these betas with the help of the data set. Betas has to estimate. Betas has to estimate. This process is called linear model learning, right? So how can we find out the betas? Model estimation. Estimation can be done by a method or known as least square method. What this least square method says, SSE is least. What is SSE stands for? Sum of square of error. Sum of square of error is least. So we have to minimize this SSE. So you have to isolate the E from this model. This is E. You have to isolate the E, taking all of the remaining terms towards the x left side of this equation. Then make a square of the error. This is error. This is the square of error. This is the sum of a square of error. So we have, this is called SSE. So we have to minimize this sum of a square of error. By the minimization of the SSE, we will get the estimates of these betas. So this is the mathematical concept behind the linear model. And this is basically a model which we call it as a machine learning model, because the regression model is one of the very popular machine learning model for scaled predictors. Your predictors must be the scale in this case. You can simplify the model by just writing these summation beta I xi plus beta naught plus error. Now this is the simple model for two predictors. Your first variable is x1, your second variable is x2, and you have two predictors we have. So if you have a two predictor model, then three betas we have. The beta naught is known as y-intercept. This is your y-intercept. And this is your slope with the x1 axis. This is your first slope. This is your second slope. So there are the two slopes. One is slope along the x1 axis and the slope along the x2 axis. These are the two axes. This is a three-dimensional model because it has three coordinates. One is x1 axis, x2 axis, and a y axis plus error. In this model, we have y as a dependent variable, x is an independent variable. Error term we have beta naught, beta 1, beta 2. These are the three model parameters.
So recording आपने क्या?
Beta naught is the y-intercept, beta 1 is the slope with the x1 axis, beta 2 is the slope with the x2 axis. Error term we have here. To isolate the error term, because we have to find the SSE. If we isolate the error term, then error term will be equal to y minus b naught minus b1 x1 minus b2 x2, and then make a square on both sides. If I make the square on both sides, then this will be equal to y minus beta naught minus beta 1 x1 minus beta 2 x2 whole square, and then take the summation on the both sides. If I take the summation on the both sides, this is called SSE. So the first step is to what? is to find out the SSE. Then the second step is to what? Minimize. So now you have to minimize this equation with respect to the beta naught, then with respect to the beta 1, then with respect to the beta 2. Because our objective is to find out these three values, beta naught, beta 1, and beta 2. So these are the estimates. So after minimization, I have three equations. This is the step of SSE, y minus beta naught minus beta 1 x1 minus beta 2. And we have x2 here in the equation, beta 2 x2 whole square. Now differentiate with respect to beta naught, equate to 0, you will get one equation. Differentiate with respect to beta 1, equate to 0, you will have second equation. Differentiate with respect to beta 2, equate to 0, you will have third equation. These three equations, if you solve these three equations simultaneously, you will get three unknowns. So this is the entire method. I'm not showing the each and every steps of finding these betas, but I am showing you the formulas of finding the betas in R. So I'm just directly implementing this procedure in background and data set in R and solving the equations by using in the background, and we have the estimated values of beta. Now, after minimizing SSE, once with respect to the beta naught, then with respect to beta 1, then with respect to beta 2, and equating to the 0, I have three equations. I am just writing these three equations here. The y is equal to b naught plus b1 x1 plus b2 x2. Then you have to put summation all over there. If you put summation all over, becomes first equation becomes summation y is equal to summation beta naught. Summation beta naught becomes n beta naught plus summation beta 1 x1 becomes b1 summation x1 plus b2 summation x2. This is your first equation. How second equation will be obtained? X1 is your first predictor, multiply the whole equation by x1 and then apply the summation. This will become x1y is equal to b naught x1 plus b1 x1 multiplied by x1 becomes x1 square plus b2 x1 multiplied by x2 and summation. This is called second equation. And third equation is multiply whole equation by x2, then apply summation. So this will be equal to x2y is equal to b naught x2 plus b1 x1 x2 plus b2 x2 square, then apply summation all over there. How these three equations obtained? By first equation is obtained by differentiating SSE by B naught and equate to 0. Second equation is obtained by differentiating SSE by B1 and equate to 0. So after simplification, we have second equation, and then differentiate SSE by B2 and equate to 0. We have three equations. Now what summation y is? Summation y is the total of the column of y. If I put the value of summation y, so that is the relation of the word problem with these equations. So I have a column of y, I can have total of y, to put the total of y here. And your n is what? Your n is the number of observations. Suppose these are the 10 observations, to put 10 here. B naught is unknown. B naught is unknown, we have to determine it. Now B1 is unknown, we have a summation x1. We have a column of x1, which is the evaluation by student. We can find out summation x1. Put summation x1 here. So we have only B naught and B1. Now x2, another column we have here, x2. Put the total of x2 here. So this is summation x2. And now first equation will have only three unknowns. One is beta naught, B1, B2. Similarly, you have to make a column of x1y. The next column is y. What? Your next column is x1y. Your next column is x1, x2. Your next column is x2y. Your next column is x1 x2 square and x1 square. So you have to make such columns. Acha, we are not going to do it manually. We are going to do it with the R. R will do it in background, and all of the totals of these will be put by the R here. One more column is needed is x2y. After making all of these columns, we have totals. All of the totals are to be put here. Then we have three equations. Then solve these three equations simultaneously. We will get B naught, B1, and B2. Now to find out the beta 2 or the estimate of beta 2, we have to differentiate the SSE by beta 2. So firstly, you have to take the derivative in power. So 2 will be taken outside and 2 minus 1. And then by chain rule, you have to differentiate the inner bracket. So if differentiate partial derivative of the inner bracket, the derivative of y with respect to b2 0, b naught 0, b1 0, and the derivative of b2 with respect to b2 is 1. So that is why we have x2. This minus taken outside, minus 2, and summation of these two brackets I have. After BODMAS rule, bracket are to be multiplied first, then a summation is to be applied. Negative sign will be taken outside to the 0, the denominator. So we have a simplified version as summation x2y, b naught, summation x2, b1, summation x1, x2, b2, summation x2 square. This is called third normal equation. So we have in the same way, I have three normal equations. That three normal equations are written here. The name of these equations is called normal equations. Now, what is to be do? You have to put these betas, these totals to be put into these three equations. Then solving these three equations simultaneously will give you the value beta naught, beta 1, beta 2. This process is called model learning, and it is also known as model fitting. Fit the model. This is called model fitting or model learning. In machine learning, it is called model learning, and in statistics and mathematics, it is called model fitting. Now we have a random set of 50 professors employed in PBA. PBA stands for the Palm Beach Atlantic University. Now students recorded the salaries of professor. The one column has salaries, and average evaluation means the form filled by the teacher, students about the teacher after in a 10 scale point. 10 means if the student assume that as a good teacher, then may give 10 out of 10. If student assume that is not a good teacher, then maybe from 1. So 1 to 10, any number student can give to the teacher. And the total number of जर्नल आर्टिकल पब्लिश्ड, कितने उसने जर्नल में आर्टिकल एक साल में पब्लिश करता है, 10, 12, 15, तो वो डेटा मेरे पास है ये. तो these three variables, salaries, publication and evaluation, this data set is defined here. Salaries of professor, course evaluation, number of publication, you can see the data here, 50 observations data here. I have provided this data set to you in the form of a CSV file. So I am going to demonstrate this into the R for some times. Now, sorry. Now you have to, how you have to write down the model in R. That is a dependent variable dv, and this symbol, and you have to write down all predictor 1. I am just writing P1 for predictor 1 plus predictor 2, P2, and so on. As many predictors, suppose I have a K predictor model, so I should have to write down the model in this way. So my variable, my dependent variable is salary. But I cannot write down the salary directly because I have a data frame behind that. So I have to write down a dollar, my data FR. This is my data FR in which I have all my data. So my data FR, you should have to write down. my data FR dollar salary, and then this symbol, tiled symbol. The first predictor is evaluation. So you can write down evaluation. How you can write down evaluation? Like this: my data FR dollar evaluation plus, this is the plus. Second predictor is my data FR dollar article. So I have three variables here. One variable is salary, other variable is evaluation with the plus sign. So sign is very important. Tiled sign in between the predictors and the dependent variable, plus sign in between all predictors. So that is the way to write down the linear model LM into R. So this is the way of writing the LM into R. Now I am going to execute this model. The first line of code, click on the first line of code, click run button. You can see a data frame is created. This is the data frame which is created right now, my data FR. After executing the first line, this variable, this data frame has been created. What this data frame contains? 50 observations of 3 variables. If you double click here, you can see the data. This is the data. Now you can see 3 columns. One column contains salary of 50 professors. You can see these 50 observations. And the next column is evaluation out of 10. The one student gave 7.4 to the teacher number 32. And teacher number 32 has 4 publications in IR. And teacher number 44, evaluation is 6.48 given by the student out of 10, and 23 publications were there. So this is my data set. And now I am going to run the second line of code. In the second line of code, I'm closing these. I cancel. Now, the second line of code is view my data FR. This is another way of showing the data. So you can see the data is there. So by just clicking my data.fr here, or by view data, you can also view the data set. The next command is what? Plot. Plot will do what? Plot will sketch the scatter plots among all of the 3 variables, because my data frame has 3 variables which are numeric variables. So some restrictions with this command is what? Variable must be the numeric variable. If you have any of the non-numeric variable into the data frame, then this command will not work and you will face an error. Now command my data. You can see the plots on the right side of this screen. Salary, evaluation, article. We have a positive slope. We have a positive slope. We have a positive slope. So these are the 3, but remaining 3 are the replica. This graph and this graph is identical. This graph and this graph is identical. This graph and this graph is identical. Why? This is between salary and evaluation. This is in between evaluation and salary. So the graph remains same. This is in between article and evaluation. So this is in between article and evaluation. So these 2 are same. So you have to read only the 3 graphs. The first graph is indicating that we have a positive slope. With this correlation here, we have a strong correlation as compared to here. Reason is what? The points are close to the line. Here the points are away to the line. So whenever I will print the correlation matrix, so you can see that we have a strong correlation here and we have a weak correlation as compared to this one here and here. So these 2 are the weak correlation as compared to this one. This one is the strong correlation. How can I put the correlation here? So very simple. Just put a command cor my data fr and run this one. Now you can see the correlation matrix. These are the correlations. You can see the correlation between salary and salary is 1. Correlation between evaluation and salary is 0.57. This is. and the correlation between article and salary is 0.8. So you can see that this correlation is very strong, 0.84. And all of you are familiar that the minimum correlation is -1, which is the strongest correlation on the left side, and the strongest correlation on the right side is +1. So strong correlation -1 and +1, these two are the strong correlation, and the weak correlation is about 0. So you can see that these are the two uh, the variable correlation among themselves. Now I'm going to execute the third command, which is building the model. The model is to be run. Just click on any point on the line and then run. So what this command does, nothing. You can see no output is showing there. Why? Because this command evaluates the model parameter and store it into the pm.lm. PA PalmBeach LM linear model, and the model parameter are stored here. The next line of code is what? PalmBeach. You want to see the values of the PalmBeach? Just I'm adding one line here, and that line is what? PalmBeach LM. Just write down this. What this command does, shows the output of the new model built by this previous command. Just running this one. Now you can see. This is very important line. These are the three betas values. Formula is shown on the first line. Formula is my data, salary, model miss, quartile symbol, then evaluation, plus this is my model. And these are what? These are the model estimates. Model estimates can be interpreted as B naught. I am writing the model here. Y is equal to 47.768 plus plus 0.77662 times evaluation. Evaluation is assumed as x1 and plus 1.062 by x2. This is my estimated model, so I should have to place a cap over there. So three values are obtained by solving that three equations simultaneously: the value of beta naught, the value of beta 1, the value of beta 2. And after evaluating these three beta, this is called model learning. Now I have the estimated model. This is called estimated model. Now we have interpretation of all of these betas. First thing is what? The data is in thousands of dollar. So you have a thousands of dollar. So actually this is not 47.76. Actually this is 47768 plus. This is not 0.7762. This is 776.2x1 plus this is not 1.006. This is 1062 x2. Now interpretation of slopes. This is the slope with the evaluation. This is the slope with the publication. This is y-intercept. And all of you have interpretation of slope and intercepts in calculus. $776 increase will be found in the salary if you gave one teacher one evaluation. If you gave 2 evaluation to the teacher out of 10, then the salary becomes $1,500. If you gave 3 evaluation to one teacher, then it will be 7 3s approximately $2,100 will be increase in the salary. So every evaluation will increase $776 into the salary. This is the interpretation of this number. Now, what is the interpretation of this number? if a teacher publish one article, means X2 is 1, then $1,062 will be increased in the salary. This is why means salary. If our teacher published the 2 articles, then 2060 multiplied by 2 become 126, 2,100 and something dollar will be increased in that salary. If some teacher publishing 3 article in a year, 3,000 something will be increased in salary. So for each article, teacher is getting a benefit of $1,062 into the salary. And what is this y-intercept is indicating? This y-intercept, which is a estimate of beta naught, this is indicating that if none of the teacher is getting evaluation, suppose a student gave 0 to a teacher who is not taking any of the class and teacher gave 0 to them, and one of the teacher is not going to publish any of the article, means number of article is 0. If both factors are 0, still the university is giving him a salary of $47,768 to those teachers who are not either getting any evaluation from the student, who are not publishing any of the article, but they are just sitting in the university and getting the salary. There are several teachers here in the university which are doing like this. So those teachers, the university is giving a base salary to them. So this is the explanation of the model, and last 2 command I will explain in a while. We are going to build the 2 graphs. One is the plot command, and this plot command is in between the fitted data and the residuals. I was explaining the residuals in earlier. So I am going to run this first command. You can see the error graph of the error here. What this graph of the error is indicating, along the line of 0, above the line, the points, and below the line, points are evenly distributed. This shows the randomness in the graph. Randomness in residuals. If this graph is having this type of shape, which means 0, above 0 the points and below the 0 the points are evenly distributed, we can say that the residuals are random. So this is the first graph, and what the second graph is a normal probability plot. Normal probability plot, this is the normal probability plot, and you can see that normal probability plot is linear, should be linear in nature. If it is linear in nature, we can call it as error are normally distributed. Error are normal. If this plot have a curve like this, or we have some point like this, so this curve is indicating that there is a violation of normality, but it is normal here. So now this is the finalization of this model. We have a model which is y is equal to 47768.2 plus 776.2 times x1 plus 1062 x2. This model is called estimated model, and we can say that the 2 assumptions are not violated by the model. In the perspective of that, we can say that this model does not violate the assumptions. The 2 assumptions are what? Error are normally distributed and error are random in nature. So these 2 assumptions random. These 2 assumptions fulfilled by this model. If you have any of the question, you can ask. Now, summary of the model. Summary of the model is the next command. In the results, you can see this summary. from here. This is the output of the summary command. So in the summary command, you can see that the formula in the first line. In the second line, you can see the residuals. What these residuals are indicating, minimum value of the residual is minus 18, maximum value of the residual is 16. This is first quartile, this is third quartile, this is median, the middle number. If the middle number is exactly the zero, which is an indication that we have a bell-shaped curve. So minimum and maximum, one quartile, third quartile, if these numbers are identical except only the sign. If it is minus 18, it is plus 18. If it is minus 3, it is plus 3. If it is 0, is the ideal situation. But we have a slight variation. It is minus 18, it is plus 8, plus 16, this is minus 3.7, this is 4.2, and it is not 0, it is close to the minus 1. So we can say that these residuals are indicating a normality in the situation. Now these are the coefficients, and now coefficients are written in vertical form. This is beta naught 47 point something. This is the estimate of beta naught. This is the estimate of beta 1. This is the estimate of beta 2. One more thing which is very important here, we should have to incorporate into this model, and that thing is these p-values. This p-value is what? 0.000 something, because it is 1.07 into e raised to the power minus 0.7. It is an indication of approximately 0 we have. And what these stars indicating? These stars is indicating that this beta is significant. Significant beta means we must have to include this beta into the model. While the p-value here is very big, which is an indication that this beta is not significant. It means evaluation does not matter. Whether the teacher get a good evaluation or is a bad evaluation, it does not matter because its p-value is 0.553. And lastly, the last beta has a very small p-value, means it is significant. So wherever we have stars, stars is indicating that we have a significant value. 3 star means it is significant at 0.1%. So it is significant at 0.1%, means beta naught should be kept into the model. Beta 2 should be kept into the model. We can ignore beta 1 because it is insignificant. The next thing is R square, multiple R square and adjusted R square. The value of adjusted R square is 0.709. If this value, this is also a part of the model accuracy. This is indicating that we have 70% of the variation in the salary is due to the evaluation and article. If we want to build the model by these two predictors, then salary changes in salary, 70.9% changes in salaries is due to the evaluation and article. So what is the impact of R square and what are the prescribed value for R square? So you should have R square to be close to the 1. R square is close to the 1 means the good model. If R square is close to the 0, indicating a poor model. The model accuracy can also be checked by R square. So we can see that 0 and 1. And in between we have R square. If R square is close to 0 means the model is poor. If R square becoming and closer to the 1.8, 0.9 is a good model. So here in this case, the R square is 0.7. Means it's approximately come like here. So we can say that appreciable model. We appreciate this model. Like in one thing is very important, and that thing is what? This p-value is insignificant. Means evaluation is not making any impact in this model. Either we can ignore the variable evaluation, right? So I can rebuild the model by eliminating the evaluation and then see the results again. Now we are going to build another model because previous model is indicating that the evaluation variable is insignificant. So we have to ignore the evaluation variable. So I copy the code from here to the last line, summary line, and paste it again and remove the one variable evaluation from the new code. So this is removed and the new model is referred to as model 2. So wherever we have LM, we have LM2, LM2 all over there. I change LM2. The outputs, new outputs are there. The new outputs showing that we have two betas. Both of the betas are significant. Estimates are slightly different with the previous one. Adjusted R square is better than the before. So by eliminating the one predictor, R square is increasing. So if R square is decreasing means the evaluation variable has an impact on salary, but it is increased meaning that evaluation does not have any impact on the salary. So what is the final conclusion of this case? The final conclusion is the perception of a student was what? Perception of a student was the teachers who are involved in research, they are giving the less time to the student class teaching. So this is the validation of the student's claim that teachers are not focusing on the evaluation, whether the student giving them a poor evaluation or good valuation, but that doesn't matter on their salary. That is why they are focusing on the publication, because publication is worthful and giving them more benefit as compared to the teaching. So the new model is a better model.